Hey, hello everyone. Enoch, are you there? Hello. Uh, Hello. Let me ask this question. Are you all able to hear me? Yes or a no? Can you please let me know? Wonderful. Okay. So if you are able to hear me, that's a good thing. And just give me a minute, please.
Good afternoon, everyone. Can you guys hear me? Can you please confirm if you can hear me?
Yeah, Enoch, I'm able to hear you.
Awesome.
So, dear faculty members, Enoch is going to walk you guys through on how you can give the feedback for the session. And then I'll get started with the last day of the training. Over to you, Enoch.
All right. Thank you so much, Bernie. So, what we are going to do right now is I am going to show you how to give a review. So, the very first place that we would like you to give your feedback is in our Google reviews. So, what I'm going to do, I am going to put the link as a sticky note, and I'm also going to put it on the chat. So when you click on the link, it would open to a page that looks like this. It would say Google Maps, and then it is going to open our 360 digit MG page. So let's give it a few more seconds for it to load completely. And there you go. And it is also going to open this particular window where you can actually rate the business. So if you enjoyed if you enjoyed the training, you could give it 5 stars, and then right underneath that you have a box where you can give your detailed feedback. So for example, if you could give feedback something like the training was amazing, the trainer was very resourceful, and whatever it is that you would like to give as a feedback, you could do it right in this box. And once you have done giving your detailed review, all you need to do is click on post. And once you click on post, it would say thank you for your review, and then you can actually go ahead and basically look at the review that you have given. So let me quickly re-explain that. So someone was saying that they cannot see my screen. So let me quickly take a poll
It's
question.
visible. It's visible.
It's visible. All right. Thank you so much. So what I'm going to do is I am going to just quickly re-explain what I just did. So you just need to go to this very link that is on the sticky note and within the chat as well. So just click on it, and it would open a page that looks like this. And it will also open a window, a small box right at the center. It will open a small box, and it is still loading. There you go. It's opening a box. And if you have not already given a review, you have to select the stars. And if you like the training, you can give it 5 stars. And then you can give all your you can write your detailed review here. And what we would request is we would request you to be very detailed in your review, so that we can use that, and it will be an encouragement to the company and to the trainers. So this is how you give the review in Google. And for those of you who do not have, or who do not have Google accounts, or you would like to give on Facebook as well, so I'm going to
Enoch,
share.
unfortunately, no one is able to see your screen, it seems. But then I'm not sure why I can see the screen.
Okay, let me stop and let me reshare. So, let me ask you guys a poll question. Can you see my screen? Yes, and then no. So it's literally half the people are able to see it. So can you see the screen right now, guys? I believe, yeah. Now the majority of them can see the screen. Okay, perfect. So for your benefit, let me quickly re-explain. There is a link that is given in the sticky note, and also there is a link within the within your chat box. So just click on that link, and it will open to a page that looks like this. And it will open a small box like this automatically, and then right here you would see the stars. So if you enjoyed the training, and if you would like the training, and if you would like all our future trainings, all you need to do is give us the stars. And if you like it, give us 5 stars. That would be really good for us. And right underneath that, there is this box, and within this box we want you to give us a really detailed feedback. So we want you to be as detailed as possible, so that it will actually help us. It will encourage us. It will encourage the trainers who are taking the time to do this training. And it will also be helpful for the company, for the people who would like to learn from us in the future. And once you have given your detailed review here, just click on post. And then you would get a message saying that thank you for your review. And that's it. That's a very fast process. And once you have given your detailed review, just click on submit.
All right. I think there is a glitch. So let me take over and let us proceed further. Yep. So there was a glitch. That's fine. I'll take it over. All right. So quickly, couple of housekeeping tasks that we shall do now is you all will be given access to AI Spry. Okay. If you didn't get access to AI Spry, then please send an email. Send an email to Smita at the rate. Let me clear that and write it properly. MITHA Smita at the rate 360digitmg.com, and you would get access. Now, allow her 24 hours and she'll give you access. Nevertheless, majority of y'all have already received LMS access. I've been receiving messages from a lot of y'all saying that thank you for providing the access. Okay. And you will find an option called Task FDP on AI and DL. You'll find such a thing. Okay, Task FDP. All you need to do is click on that, and you'll find all the techniques which we have learned. Okay, and alongside that, you'll have quizzes. Okay, so there you go. You will also have the code. Additional code also will be there. Python code, the data set which has been used. You can download these. But when it comes to the slides, you cannot download those. But nevertheless, you can actually read it. Okay, you can read it online. We have computer vision, we have convolution neural network, recurrent neural network. I doubt we'll have time, but nevertheless, we have given you the details. And there are a few recommended videos. You would come to our channel, and there are a few videos on AI and deep learning. Enjoy your session, and we would also enable the certificate option shortly. Certificate option would be enabled, and you can actually download your certificate. Okay. All right. But for the next a few days, you can have you know access to these. It will be for the next 3 months. After 3 months, if you still want access, we don't mind extending it to another 3 months. But by default, we can give you access for 3 months. Next, what if you have any doubts on the topics which have already been discussed? From 12 p.m. to 5 p.m. from Monday until Friday this week. From next week onwards, Monday to Saturday at the same time, you can connect to our YouTube live and ask any questions you have. We have opened this for everyone. Anyone who has doubts, clarifications, questions, you are free to reach out to us and ask your questions, and our team will respond. Right? There'll be a lot of junior trainers also, but if they are not able to answer, we will make sure that we get back to you via email or over call. By some means, we will reach out to you and clarify your doubts. Okay. So yeah, sure. If you provided email, you would. You received, right, Ashadati? Yes. Yeah, a few of you all are yet to receive. A few of you all have received. You receive that. If you drop an email, you'll receive. Yeah. If you drop an email, you would have received. If you didn't drop it, please drop it. Please send an email to smita at the rate 360digitmg.com. Send an email to her and she would be giving you access. Okay. Thank you so much. Now let's move on. So we shall continue further. I firmly and strongly recommend and request you all to give reviews. It'll be helpful for us as well. Okay. So here, yesterday, we started off by discussing about convolution neural network, right? And we discussed about a lot of things such as how convolution neural network has become famous in 2012 in dealing with images. And then we discussed about the applications of convolution neural network. And we discussed about why multi-layered perceptron is not a good fit when you deal with images. What are the two reasons? The two reasons are that the number of weights that your model has to learn would be very high, number one. Number two, you'll have to access each and every pixel. Okay, you'll have to access each and every pixel value. Okay, only then you would be, you know, able to analyze. If it comes to MLP, which is a waste of effort and time, right? Because all these border pixels, these pixels really does not make any sense in determining who is there in this image. Yeah. And then we discuss about this, that when you have an image and when you have a filter, When you convolve your filter on the image, you get an output. And we also discussed this scenario wherein the filter will consume the complete depth. And when you apply a filter on an image, you get something called as activation map. Okay. If you apply 6 filters, you would get 6 activation map. And what do you mean by activation map? Activation map is also called as feature map, and it extracts the features from the image. The most raw feature that one can extract from the image is the pixel intensity value. You can also extract the edge features, you can extract the blob features, and there are many other features that can be extracted. Conv relu pool, conv relu pool. This is a typical sequence in which you define your layers and then you connect it to fully connected network. Then we discussed about certain formula or formulae rather, and how does it work when you have stride equal to 1, how does it work when stride equal to 2, and how does it work when stride equal to 3. We discussed these. When you have an image, when you apply a filter, you get an output image. What should be the size of that image, right? That's also we discussed. This is also something that we have discussed, n minus f by stride plus 1. We discussed about padding, zero padding, the border pixels. Then we discussed this wherein if you have an image, if you have multiple filters, how do you proceed further? How many parameters is your model going to learn? This is also something that you get to understand. Okay, then we discussed about pooling layer, max pooling, how it works and all that. Then this is the AlexNet use case basically. Do you know what people do not have the compute? Compute means you do not have the processors, GPU machines, which are very powerful to experiment many things. Let's look at AlexNet, which won the first place. First place. Alex Krasevsky and his team from University of Toronto have come up with this network, which won the first place. So what people usually do is they take the same network architecture and try to reuse this. And here what they have done is, it was very complicated. They experimented for over a year, right? More than 1 year they experimented to get at this, wherein they take the input image, you take the convolution neural networks, right? 96 11 by 11 filters. They've used stride 4, padding 0. Then there was a max pool. Then we have batch norm. Then conv pool norm, right? Conv max pool. Then you have your fully connected networks, wherein you have 1,000 neurons. Okay, details retrospectives basically. And what did they use? They use ReLU activation functions. They use batch norm, which is used for regularization purpose, avoiding overfitting. Data augmentation, because it is images, they have used batch size 0.5. Sorry, dropout as 0.5. Batch size was 128. SGD momentum, you have momentum, Nestrov momentum, etc. They have used a learning rate of 1 into 10 raised to the power minus 2. And they reduced by 10 manually when the validation loss plateaus. We discussed this, right? Early stopping, in that we discussed this. They've used also L2 weight decay, which is also another regularization technique. They've used 7 CNN ensemble models. All of these things. Okay, and then, yep, this is how They have built the neural network. You can use weight decays, you can use dropout, you can use drop connect, you can use batch norm, and there are various other techniques that can be used, such as covariate shift, maintaining adversaries, so on and so forth. What do you mean by adversaries? Since this is there, let me explain. Adversaries means you take your input image, and when you use it for prediction, say you got highest probability for tiger. Okay, that means this image is tiger. Wonderful. So it could detect accurately. Now, if you take a Gaussian noise, or some noise basically from uniform distribution in between this range or any range of data, randomly take values and fill it with each and every pixel value. So for instance, if you have the pixel values, each pixel value should be filled by one of the values randomly. Okay, randomly do that. When you do that, and when you add it to your original image, the image looks as is. The image will look as you see your input image, right? Exactly, it will look the same. It will appear exactly the same. However, when you supply this to your algorithm will get confused. And this is how people safeguard the data from hackers. See, what is the job of a hacker? He needs to hack and get the data. Until they get the data, they'll be fiddling with the system. If you want to give the hackers an illusion that they're getting access to the data, but when they open that, they should find all junk in that, right? At the face of it, when you look at it, you might feel that it's a tiger, but when you actually start using it, it's nowhere a tiger. See, nowhere a tiger. It says that this is velvet, this is thimble, purse, pillow, brain coral. There's no correlation between the image and the classification results. And a few companies also use something called as honeycomb. What they do is they purposefully, if you have multiple servers, purposefully one of the server will be having a loophole. What hackers do is quickly they scan all the systems, and wherever they have a loophole, they actually enter into that loophole and try to access the data. In the system, they'll be given an illusion that they've actually hacked and they actually got access to data. But when they try using that data for any other purpose, it will not work basically. It doesn't work. Okay, and then all the steps which the hacker has taken would be captured, and the other servers which actually have the actual data, right? On that server, they will try to ensure that all the steps the hacker has taken is addressed so that no hacker enters into the system. That's called as honeycomb. In that scenario also, when people hack in, you'll be giving these kind of adversaries basically. Adversaries means data which is not accurate. It will give you an illusion that it's accurate, but it's not accurate basically. Okay. Now let me go to CNN and we shall discuss this. RNN, CNN, where is that? Yeah, here it is. Okay, I'll first take this code, this piece of it. I'll run that code and explain how it works. And then what we shall do is I'll run the other code and explain the concepts. Okay, I'll not be having time to walk you guys through each line. However, at a high level, I will be able to tell you on what happens and how it works. Come up. Yeah. Let me launch Spider. And the last 15 minutes today, I'll be just addressing your questions. Okay. You might have a lot of questions, so I'll be addressing your questions in the last 15 minutes. Of course, see, do not feel that this is the only forum to ask questions and then this guy won't be available. Don't worry. Again, I repeat, from 12 p.m. to 5 p.m. Starting from next Monday, assume from Monday to Saturday, you can log into our YouTube live. Just go to our YouTube channel. If you subscribe and click on notify, it will notify you whenever we go live. Log in, ask your questions. There'll be a lot of junior trainers attending these. They will be able to answer at least 80% of the questions that you have. If they cannot answer any, they notify it to us, and at nights we sit down and we, come up with the answers, and then we also communicate. So don't worry from that perspective. Yeah. Don't assume that this is the end of the world. No, not at all. All right, next. So I'm importing TensorFlow as TF, and I want to run this, wherein you're testing whether GPU is available or not. CUDA is something which is related to NVIDIA. Let me show you that also. If you want to use your GPU machine, you have to say download CUDA. CUDA toolkit is from NVIDIA. Your artificial intelligence related GPUs, etc., are developed by NVIDIA on one side, on Intel. NVIDIA is extremely famous, extremely famous. Oh my God, I think it's a sheer luck, but then they are doing amazingly well. Okay, CUDA programming, CUDA toolkit. Yeah. Anyways, this is one thing. Let me run it. If it says true, that means GPU is being used. So yeah, GPU is being used. If you do not have a GPU machine, if you have a CPU machine, can you run CNN model? No, you cannot. Can I run ANN model on a CPU machine? Yes, you can. MLP, you can run that. But CNN models, you cannot run. So you need a GPU. Oh, so should I go and purchase one? And how much does it cost, etc.? So let me tell you that I would not recommend you to purchase one. I would like to, I would request you all to make use of the resources available. So if you go to something called as Google Colab, sorry, Google Colab, when you click on this, it would open. I keep using for some other purpose. You say new notebook and it would open this window. It's coming up. Type your program here, 1 plus 1. For the first time, it would take a while. So whatever lines of code you're running here, whatever you're trying to run here, you run it here, that's it. Say you want to run these lines of code, you just copy it and you run it here. So for that, you just need to say plus code and click on run. I copied and pasted from here. Clicking on run. Yep, it worked. 55,000. No, I want to use GPU. Okay, for that you need to go to runtime, click on change runtime type, do a drop down, and you have GPU and TPU. GPU stands for graphical processing unit and TPU stands for tensor processing unit. CPU, in comparison to a CPU, I would say GPU is 10 times faster. In comparison to your GPU, TPU is another 10 times faster. GPU is 10 times faster. TPU is another 10 times faster in comparison to CPU. CPU, GPU is 10 times faster in comparison to GPU, TPU. TPU is from Google, right? And it's your Google's own make basically. You can change the runtime to any type and then let me change it to GPU for instance and save it. Is it free? Yeah, it is free until you use $300. That means if you go with very high-end configuration, if you want to add the RAM, okay, if you want to do all those kind of things, basically, then it will be consuming you. But if you use it for basic practice and all that, that's okay. A 300 GB GPU, sorry, $300 computer. That is, I'm using a laptop remotely. I've connected to a laptop here by going to Google Colab. Remotely, I've connected to a server or a computer. Okay, which is worth only $300. Cheap one. I can use it. Okay. So don't invest in purchasing any laptop. It doesn't make sense until unless you are extensively working on research and doing consulting for various companies. Hmm. Okay, next. So what are we doing here? We are importing TensorFlow.keras. In TensorFlow latest version, that is version 2 upwards, you have to write in this way if you want to use keras. So you want to import layers from TensorFlow keras import models. Then you come up with a sequential model, model.sequential. Okay, model.add. Okay, here you're saying you want to add 2D convolution layer. So you're trying to add here a 2D convolution layer. 32 3 by 3 filters is what you want. 32 3 by 3. And you want to use activation function ReLU. And then the size of your input image is 28 by 28 by 1. 1 means grayscale. 28 by 28, when you multiply, you get 784. Those 784 are connected to how many? 3 by 3, 32 such 3 by 3. 3 by 3, 3 by 3, 3 by 3, 3 by 3. 3 by 3 means 9, 9, 9, 9. How many such? 9, 32. And then you are doing a max pool 2D. After that max pool 2D, what does max pool 2D do? It will reduce the size of the image. So let me tell you that initially when you have an image of this size, okay, you go and extract each and every minute details. This is the input image that you're supplying, and the initial layers, what do? They capture the low level information. Means in pixel intensity values, edges, basics. Basic things about the image would be captured. Those are called as low level. And then to the next layer, when you supply, you don't need such a big image again. You can reduce the size of the image because you have already extracted all the low level information from this image. So even if you reduce the size of the image a little, doesn't matter for the next layer, because next layer captures what features? Mid-level features, such as eye of a person, nose of a person, mouth of a person, etc. Right? It's really not bothered about various other things such as what is the background, okay, what is the background color, so on and so forth. Then when you supply this to the next layer or the final layers will capture high level information, meaning face of the person. For that, you don't need again such a big image. You can reduce it further. And if you reduce it further, you'll get the image. I mean, you'll get the face of a person. And finally, you classify on what that particular image is. Initial layers, low level features. Next layers, mid level features. Next, our final layer will capture high level features. And finally, it will tell that, okay, this image belongs to Sharath. And Sharath has entered the office today at 9 a.m. That information gets captured. Okay. So you're using all those, and the immediate next layer would be max pool. Another thing that you need to understand is max pool will only reduce the size of the image. It will not learn any parameters. Its job is only to reduce the size of image and does not learn any new weights or parameters. Not new weights, it doesn't learn any weights for that case. And next what happens is you again connect it to another set of 64 3 by 3 conv layers. Remember conv pool, conv. I was saying that's how it is. Conv pool, conv pool. 2 by 2. Why 2 by 2? Because images are two dimensional. You'll have X and Y, right? Two dimensional or width and height. And you're using activation function really. Then you pass it to max pool and then you pass it to again another conv 2D. 64 of those, 3 by 3 this. Hey, how do I decide 32, 64 and 64? It's up to you. The more conv 2D layers you use, more features of the image your model learns. But then one thing, it'll be time consuming. Another thing is you might run into the risk of overfitting your model. Okay. So yeah, you decide based on your logic. And then I will run these and say model.summary. When I say model.summary, it shows you on how many weights your model is going to learn. Right? 32. Why 320 parameters? Because you have 3 by 3. 3 by 3 means 9. And then you'll have one bias also. So it'll become 10. And 32 into 10 will be 320. 320 weights is what, or parameters is what your model is going to learn. Max pool, as I've told you, doesn't have any parameters that it will learn. And then in total, there are 55,744 different parameters that your model is going to learn. Next, what's happening next is conv, max pool, conv, pool, conv, right? And then you're connecting that to something called as flatten, because what happens is here you have 64 3 by 3. That means It will look like this. 1, 2, 3, 4, 5, all 64. All these you're combining together and you're supplying it to your network next. You're combining all of those. How do you combine? By doing this flatten. Okay, you have to flatten. After flattening, you're supplying that to the next layer, which is layers.dense, and you're supplying it to 64 neurons. You flatten it and then supply it to 64. And which activation function are you using here? ReLU activation function. Hey, do I need to always use ReLU? No. You can try out other activation functions. But based on research, it is found that if you have a ReLU activation function, it works very well. And then you're supplying this to the next layer, wherein you have 10 neurons. And you're using softmax. When do you use softmax? When you have more than 2 categories. And here it's again the same exercise, that same data set of MNIST, Modified National Institute of Standards and Technology, wherein you have handwritten digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you need to classify on what that image belongs to. Does it belong to class 0 or 1 or 2 or all of any of these? And then you say model.summary. So let me run these. Next. Keras has a specific module called as datasets. And from that, you can directly import MNIST. Previously, what I've done is I've extracted or downloaded from MNIST dataset from somewhere, and then we have uploaded that into the tool. But here we are importing directly from this library. And then you have TensorFlow Keras utils. From that, you can import something called as 2-categorical. I'll let you know why we need that. And then to load that data set, you say mnist dot load underscore data, which should actually load the data. Okay, and then do you know what the data set already has? Training images and training labels. Labels mean 0, 1, 2, 3 until 9. And then you also have test images and test labels. So you're loading that data set and assigning it to training images, training labels, test images, test labels. You run that. Then what we are doing is, here when we declared, when we defined our network, we have clearly told that the shape of the input image will be 28 by 28 by 1. Okay. So what we are doing here is, you're saying that within the training data, you have 60,000 images, and you're saying reshape those 60,000 images into 28 by 28 by 1. Why? Because if you say that your input layer would be 28 by 28 by 1, which is 784 neurons, and suppose one of your image, assume one of these 60,000 images is of 28 by 29, it will start throwing error, because your network will understand only if your input images are of 784. Otherwise, it will start throwing error. Right? So you have those. So training images dot reshape, all these. Reshape to a specific shape. Then what you do is, you're converting all these images to float 32 format. All these images, if you see, are in the form of unsigned integer format. Integer means 1, 2, 3, 0, -1, -2, -3 in that way. But what happens is in your network, when you supply to your network in this way, all these weights that are assigned, all these weights will be in decimal format. That means float format. And if your weights are in float format, and if your inputs are in integer format, and then if you multiply integer and float, why do you need to do that? Because the formula is b plus w1 x1. So you multiply w1 x1, weight and input. When you do that, input is in integer format, weight is in float format, it will throw an error. Hey, I didn't understand. Your model will start crying. So you don't want that to happen. So you convert that to float 32. And also you're dividing it by 255 because you want to normalize or standardize. I think in the second day or third day, I think, right? We discussed about normalization, standardization. Why do we do it? To make the data scale free, basically. Okay. And when you do this in a neural network context, what happens is the convergence becomes faster. Convergence, what do I mean by that? If you have a network like that, if you're moving in that way, it will come faster to the bottom of the valley. It will move faster to the bottom of the valley, basically. So you do it in that way. Okay. And then let me run until here. 2 underscore categorical and 2 underscore categorical, right? Now, if you said, I want to take all these inputs of training data, all these inputs, sorry, labels rather, not input output, labels. You have this first one is digit 5, this is digit 0, this is digit 4, digit 1, digit 9. In that way, you have all the digits. Okay. So you take all those digits and you convert that to categorical format. When you convert it to categorical format, what's happening basically, right? What does that mean? This will do one hot encoding, my dear friends. It will take all those numbers and then do a one hot encoding. Meaning if it is 5, right, what happens now is it will create like this numbers. If this is your that output variable label, then it will create 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The question is not one hot encoding. The question is, why are we doing it? What is the need to do, right? That is more important, right? It shouldn't be more mechanical for us. If it's 5, for instance, 0, 0, 0, 0, 0. This is 5. So against 5, you'll have a 1. Rest all are zeros. Okay, if here you have a digit 0, then against 0, you'll have a 1. Rest all will be zeros. Why is this the case? Let me understand. Let me help you understand. The reason why you do this one hot encoding or why you convert to categorical format is because you want to calculate categorical cross entropy. What does that mean? This is actual data, right? The actual data which is already given to you, you're taking that and you're putting these one hot encoded values. Now, when you do the prediction, right, what will be the predicted value results? They will be probabilities. Okay, there'll be nothing but probabilities. It will be like this. You'll again have same thing: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then you'll put probabilities underneath that. Like this is 0.01 probability that it is 0. Okay, 0.1% probability that it is zero point 0.1. Say you're doing it for this row. 5. 0.02% that it's so much, 0.18 that it is 3. In that way, you will have all the probability values. Okay, 0.15, 0.6, okay, then 0.0001. In that way, you'll have probabilities. Now, what is categorical cross entropy? If you remember, I equal to 1 until n minus p into log of pi into log of qi base 2. Okay, you have 10 class, so it will be summation of I equal to 1 minus until 10 pi into log of qi base 2. When you substitute I equal to 1, p1 into log of this, then if you substitute I equal to p2 into log of q2, in that way. So all you do is 0, this is p, this is q. 0 into 0.01 plus 0 into 0.1 plus 0 into this, 0 into this, 0 into this, 1 into this, 0 into 0. 0 into everything is 0. So ultimately you will get nothing but 1 into minus 1 into log of zero point 0.6 base 2. When you solve it, you get a loss. That is categorical cross entropy. Just to ensure you calculate your cost function properly, we use categorical cross entropy here, and then we convert this into categorical. If it is not in one hot encoded format, there is no way your loss function can be calculated. So pre-processing is very, very important. These steps that you see until here, you're loading the data and then doing some pre-processing. You're ensuring all the images are of same shape so that there is no error. You're converting everything to float 32 and dividing it by 255 to ensure that there is no error, right? And then you're converting it to categorical format so that there is no error when you run the code, right? So you define your model, you have taken the data, you have done the pre-processing of the data, then you're compiling the model here. When you say model.compile, you compile the model. So always remember, specify the model, then compile the model, specify or define. And once you compile the model, the next step is you fit the model. 1, 2, 3. And for doing this, you need data. So you load the data. You first of all collect the data, load the data, and then you pre-process the data in the format that you want. See, majority of the people, right, what they assume is data magically, some magic will happen and data will automatically come to me and sit in my computer in the form of Excel file or CSV file. And it'll be very clean. And then I get started. I just want to know about algorithms. Extremely bad attitude, extremely wrong attitude. 60% of the time of a typical data scientist or AI expert is spent on what? Understanding the business problem, collecting the data, performing data pre-processing, data cleansing, I mean, and model building is just 20% of your time. And the sad part of the trainings in and training industry in India, the saddest part is they are focusing only on this 20%. And when people interview, including me, I just get pissed off when I interview people, who are having theoretical knowledge, who get trained. Of course, who get trained, we want to hire them, but then they only speak about algorithms. Who wants that? No one wants that. Auto ML is coming in a big way. By the time a student completes BTech 4 years, trust me, there won't be all these things that you have taught for the first 2 years. Again, the student becomes irrelevant in the market. Again, there'll be a gap between the industry and academia. Right? That's why a lot of colleges, universities, these skill organizations, government organizations are ensuring that they bring in the experts from the industry, because what happens in the industry is important, and that is what students have to be taught. Not this thing, which is in the due process of being automated, and still learn about this algorithm, this regularization technique. Okay, sure, you need all that, but should that be the only thing that you learn? Absolutely no. Absolutely no. And trust me, one more thing. If I go to companies such as Coca-Cola, and if I want to implement uh, an AI project and solve it, no one asked me even until date. It's a 3-year project on what is the math that you have used. Okay, what are the algorithms that you have used? What did you change in the algorithm? None of them asked. Why would they be interested in that? They would be interested in only one thing. Hey, I had a problem, did you solve it, yes or no? And someone who doesn't want to become a mathematician, someone who doesn't want to become a statistician, why should we thrust all these things onto them? Right? That's purely my take, but that is extremely valid in the industry. When I speak with the folks from the industry, they echo this. Let's see, you teach so much of math, so much of depth into the algorithms. Where are the people going to use that? Okay, people who want to get into research, for them it is absolutely valid, but not for people who want to get into companies and work on data science projects. Frankly, this is what industry is echoing. So for you also, when I'm not sure I'm so great as you guys to tell you on what has to be done, but then my suggestion would be, when you train the students, please ensure that you give them holistic view on how to collect the data, where to collect the data from, how to load the data, how to pre-process the data, because 60% of their time they spend on that. Only 20% of their time they spend on algorithms. So don't make them industry irrelevant. Okay, that's the reason why Task has taken this task, and I'm really very happy to associate with them in delivering these trainings. Anyways, let me complete this part. So here you have to compile the model. When you compile the model, you have to give three things. One is, what optimizer do you want to use? There are many optimizers: Adam, Adagrad, Ada Delta, RMS prop, many things, SGD, mini batch SGD, and all that. Here we are making use of something called as RMS prop. And then we are using a loss function. Since you have a multi-class problem wherein you need to classify whether it is 0 or 1 or 2 or 3 or any of those, since you have more than two categories, you're going with categorical cross entropy. And the metric that you want to measure is accuracy. So let me compile this model. There are a couple of pre-processing tasks, and then we are going to compile this, and then you fit the model. When you fit the model, it is training images and training labels. So you have X and Y, and then you want 5 epochs. I mean, you can give number of epochs is empirical, you can decide upon that. And there are a lot of grid search techniques, you might want to explore that. When batch size equal to 64. Again, batch size is something that you want to decide. Usually it is 2, it is a power of 2, like 16, 32, 64, in that way. Why is that so? Because the GPU RAM is to the power of 2. So you fit the model. So you have the accuracy here. Okay, epochs are running. One more thing before, quickly come up, come up. Of course, I'll show you once again also. So here, if you see GPU is being used, 4% of GPU. Now this GPU will become 0. right? So the moment you run your CNN, GPUs will take off. And we got an accuracy here of 0.9939. You can also evaluate, this is on the training data. Remember, you need training accuracy and test accuracy. This is the training accuracy. You say model.evaluate on the test data and verbose equal to 2. When I run this and store the test loss and test accuracy in these, you have a test accuracy of 0.9903. Okay, let me run it. There we go, 0.9903. So when you say verbose equal to 2, it will just throw a single line at you. You can have verbose equal to 0 and 1 also. 0 means it's a silent execution. You'll not even see this line. 1 means it will show you the progress bar when you test on the test data. And here you have the training accuracy, which happens to be 0.9939. And you have the test accuracy, which is so much, 0.9903. These two are very high and close to each other, so you conclude that it's a right fit. If it if training accuracy is high and test accuracy is less, maybe it turned out to be say 0.89, it's very less. So that means your model is overfitting and you use regularization techniques such as dropout, batch norm, okay, L2 norm, things of that kind. Okay, so let us quickly take a break and let us be back by 6:15, and we shall discuss about a few more important things about CNN. And then I'll probably spend last 15 minutes only addressing and talking with you all and understanding your queries. So let's continue and complete the remaining part as well. Okay. So let us complete this. Our team is there, friends. I know, just to ensure that the training flow is not hampered. We have a team who is answering your queries behind the scenes. Yeah. Okay. They. I'm really thankful to them because they invest a lot of effort. All right. Next. Okay. Where do I have the full CNN part? I think this. Okay. So we have run the code until, yes, so let me input from here. So what I'm going to take, I'm going to do now is I will run a lot of code, and some of the lines of code I'll be very, very fast because we need to run, I need to explain you on how things work with respect to pre-trained models and all that. But nevertheless, we'll be giving you the code, and so now I am sure you understand on what is the kind of depth that we go to, right, as part of our 80 hours training. Anyways, so let me run this. We have this data set wherein we need to look at the data and then look at the images and classify the images as cats or dogs. And we have basically three things, right? Training data, in which you have cats and dogs images, and these are the images basically, right? Cats, and you also have dogs. The moment an image is given, you need to classify on whether the image is cat or a dog. Okay, that's what you need to do. So I'm in the first place giving the path of the complete file. I'm giving the path to the base directory, to the training directory, because within this you have train, validation, and test. You have all three. So I'm giving training, validation, and test. Within training, you have cats and dogs. Cats and dogs. Within validation, you have cats and dogs. Within test, you have cats and dogs. Okay, all that is given. And then you can print these and see how many data points you have. Oh, didn't I import OS? I didn't. So let me import that. So here, when I run this line, all I'm doing is I'm saying print length of operating system list directory, meaning it will go to this directory called train underscore cats underscore directory, which is this one, right? Train underscore cats underscore directory. So it will go to this path, select all the images and get the length of that, and then print out the results. You have 1,000 cat images, and then you have 1,000 dog images, and then you have 500 cat and 500 dog images in validation and 500 in test. Then you are defining your model. You are importing the required libraries and the corresponding modules within that. You're creating a sequential model. Here the images are of size 150 by 150 and by 3, meaning color image. Are all the images 150 by 150? I really am not sure because um, let me get the details of it. Hmm? Okay, let me right click and see the properties. It's not 500 by 500, see friends. Oh, sorry, it's not 150 by 150. It's 407 by 281. That's the dimension. I cannot zoom it. Yeah, Windows, right? So I cannot zoom it. But nevertheless, people who are connecting from mobile might feel that issue. So but nevertheless, your whatever be the size of the images, you're considering the size of the images here to be 150 by 150 by 3 color image. So you're creating the conf pool, conf pool, conf pool, conf pool, flatten. Then you have a dense layer. And my question is, why do I have a single layer here, single neuron? You have a single neuron because it's a binary classification problem. Is it a cat or a dog? It's a two class problem. So you have a single neuron and the activation function is sigmoid. If you have multi classes, you use softmax. If you have a single, you use sigmoid. And then you come up with a summary. Then you have optimizers from TensorFlow Keras input optimizers. So model.compile, you're taking the loss function as binary cross entropy. And you're taking the optimizer RMS prop and the learning rate and metric as accuracy. Why did I import this directly? I think I haven't. Oh, I imported that also, right? Yep. And look at the number of parameters. 3 million, 3.4 million for that case. Weights is what your model is going to learn. And if you run it on your typical CPU machine, it will not run, friends. Okay. All you need to do is make use of Google Colab. Okay. So you specified the model. Once again, it's the same thing. You specify the model or define the model. Once you define the model, defining means creating all the layers. Then you compile your model. Once you compile the model, you pre-process the model. So in pre-processing, you're rescaling the images by 255. And then you are ensuring that all of your images are of the same size. Then you're saying that the batch size should be 20 images each, and then you want to process them. Okay, of course, I'll not have the time to explain each and every code, my dear friends, but then, yeah, to some extent. And then here, I'm fitting the model. Here, I'm changing model.fit to model.fit underscore generator because here, I mean, these lines of code is not needed. So let me just remove that. It's there for some other purpose, ignore it. Because you're taking that image data generator and you're taking 20 images and converting all the image to converting them to size 150 by 150, right? So when you apply those kind of generators, you use this generator. Okay, so you're taking your training data, you're coming up with 30 epochs. Steps per epoch is 300. Okay, that means how many ever images you have. Say you have 2000 images, for instance. If you traverse all these 200 images, it should be one epoch. Okay, so it will take 300 steps. Ideally, if you have a surface, it will take 300 steps to complete one epoch. Within 300 steps, it will try to reach the bottom. That's what it means. And you have validation steps. This is after how many images. Say after you complete 50 steps, you want to test on the validation data also. Because once you train on the training data, You're also expected to test on the validation data. Okay, that's the reason. So if I run this, you will get some idea basically. So let me run it. So it has divided that data into 300, and it's taking 300 steps to reach the bottom. So one of 30 epochs. Okay, and in the interim, let me show you that, you know, 29%, 27% of your GPU is being used. If you use your CPU, it will throw an error, number one. If it doesn't throw your error, your CPU will shoot up to 100% and it will jam your resources. Okay, now we reach the third epoch. Let it complete all the 30 epochs. While it completes 30 epochs, let me take your questions. Okay. Yep. Thank you, Jyotsna, for that. Thank you, Deepika. Yeah, please ask me questions now. Where would I download certificate? So what we will do is, Sukhveer ji, we will be posting a small video on how to download and where to download on your WhatsApp so that it's easier for you. Yeah, Krishna Rao, I think I increased the font size probably. Okay, Aparna says, in Google Colab, if I need to run code on my data files using GPU, how can I upload? Oh, it's very simple. You can put it on your Google Drive also. Okay, you can basically file. Um, you can actually put it on your Google Drive. Let me put it in that way, right? And then you can start accessing. And here also you have various options, right? How do you want to connect to your files? Various things. Okay. Usually what I do is I put it on a Google Drive and then I access it from there. You can just Google out how to put it on Google Drive. Again, that's a big process to explain. Ah, any questions? How should we select GPU? Where in this, you just go to runtime, manage sessions. Oh, sorry, not manage. Runtime, change runtime type. And here in the drop down, you select your GPU or TPU. Okay. I experiment with sometimes GPU, sometimes this thing. Sometimes I increase the RAM. I pay to Google and then take it forward. And then yeah, thank you so much, Raghuveer. Thank you all. It's a real honor to be training you all. CNN is used on images, Doctor Narendra, and CNN is used on images, and RNN is used when you have sequential data, time series data, or when you have textual data. That is when you use this. Yeah. It will be there on the learning management system, Ramya. Datasets also will be there. From here on, what path would you suggest for us to learn more about data science or real life applications? Hey, this is Santosh. This is just a, I would say we have just scratched the surface. Okay. And I don't want to hard sell anything at you guys because this was a free training. Free is free, right? But if you want to do any advanced training, I would suggest you to, there are two things. One is go with AI and deep learning codes that we have, wherein we are going to get into the nerves and the depth of the training, wherein if you look at just CNN, right, we will help you understand how to run a 1D convolution transpose convolution, how to visualize the convolution layers, how do you do transfer learning. Okay. And then when it comes to image processing, there are a lot of things which we haven't done. Those are all part of OpenCV 4.0, RNN, LSTM, GRU, CNN, RNN variants. How do you combine them? fast RCNN, mask RCNN, and then autoencoders, variational autoencoders, deep belief networks, GANs, super resolution GANs, right? Reinforcement learning or Q learning, speech recognition system, automatic text generation within which we use the latest of the techniques such as BERT, ExcelNet, and all that. And then you learn about auto AI, right? Explainable AI, stuff of that kind. So you can enroll for this, or if you want a very even comprehensive training, then it's professional course of data science and AI, wherein it's a proper 6 months program. It's for 300 hours, and you just look at the course modules, you'll just be surprised, amazed at the kind of depth that we are covering. You would not find it in India, certainly, right? I can bet on that. Okay, that's to answer. Yeah, Ramya, you will get that on your learning management system. Ramya, learning management system. This is the learning management system that we have, and you will have the Python code, etc. here, and you have the data sets, right? You have the data sets here, OpenCV data sets, right? Data here. The here is where you can download. GPUs is majorly used in AI applications, Usman. My God. Okay, I'll explain convolution operation because yesterday also I think our friend asked this same question. So while let me see this algorithm status. Okay, it's in 19th epoch. So let me quickly complete that. Let me go here. So do you know what? To explain quickly, this is all math oriented. So again, I'm not a guy who is fancy about math, but nevertheless, I don't mind getting into the depth of it and explaining. Let me explain. Okay. There is something called as cross correlation. Okay. What do you mean by cross correlation in the first place? This is some kind of mathematical operation like you have addition, subtraction, division, multiplication. In that way, you also have cross correlation. Let me apply this on an impulse image. Impulse image means the central pixel here will be 1. 1 means white. Rest all will be zeros. So 0 to 255, 0 means black, 255 means white. Okay. And if I normalize it, meaning if I divide everything by 255, this will be 0. 0 by 255 is 0. 255 by 255 is 1. So it'll be in the range of 0 to 255. When I apply this on this portion here, what would happen? 0 into A plus 0 into B plus 0 into C plus 0 into D plus 0 into E plus 0 into F plus 0 into G plus 0 into H plus 1 into I. Only this I gets multiplied by 1 and the central pixel here will be I. Then you move it one stride at a time. So let me move it by one stride. If you move it by one stride, it will go here. And what would happen? 0 into A plus 0 into B plus 0 into C plus 0 into D plus 0 into E plus 0 into F plus 0 into G plus 1 into H plus 0 into this. So 1 is getting multiplied by H. So this central pixel value will be H. In that way, if I multiply, you'll get G here. Okay. And then you'll get F here, E, D, C, B, A. So what is going to happen here is when you apply cross correlation of this on this, what is happening? You are getting the same filter as output, but the filter is getting flipped both sides. It is getting flipped both sides basically. So that means if it's like this white portion comes here, it's not getting immediately flipped. If it gets flipped in this way, white would have been here, this would have been here, this will be here, this will be here, this gray will be here, black will be here, right? But it's getting flipped on this side also. Hence, this is coming here, this is going there. Okay. This, a few people feel that it's a disadvantage because when you're applying a filter on an impulse image, you should have got the same filter ideally. But the filter is getting flipped on both sides. Hence, people came up with another operation called as convolution operation. Okay, let me explain this here. How many boxes are there? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 by 7. And here you have 3 by 3. Okay, let me put it here. So if you have 1, 2, 3, 4, 5, 6, 7. And if you have 7 here, 1, 2, 3, 4, 5, 6, and 7. And then if you have 3 by 3, 3 by 3 filter. And you have A, B, C, D, E, F, G, H, I. This is f of I comma j. This is the filter basically. This is your, oh, sorry, this is the input f of I comma j. And this is your filter, which is h of u comma v. And then this is your output image. And here, say you have a central pixel which has 1. And when I apply this filter on this, how does it work? First of all, let me give you the numbers. Say this is -101, -101. Okay. So when I take u, u will be from -1 to 1. V will be from -1 to 1. And then you have this function. If I take u as -1 as v as -1, what happens is -1 is g. So you multiply g into f of I minus u and j minus v. What does that mean? That means that if f of ij, let me take this pixel. Okay, let me apply this on this. I minus 1, j minus 1, what it does is it will take this position of this pixel to here. You're taking it 1 pixel above, 1 pixel on this side, so it will go here. If I apply this on this patch, or this, if I apply this on this patch, what would happen in ideal scenario is this I would get multiplied by 1. And in your output image, you get I. Okay, for this pixel basically. If I apply on this. But now what's happening is you're doing I minus u and j minus 1. So you're taking it 1 pixel above and 1 pixel towards the left. Okay, or let me tell you, sorry, let me tell you in a different way. So since you're taking -1 and -1, which is g, when I say I minus of -1, j minus of -1, what would happen ideally? You say I plus 1 and j plus 1, right? I plus 1 and j plus 1. So what is going to happen is your patch, you're going to apply on this patch. Okay, this image on this patch. And if it's I plus 1 and j plus 1, and if you're interested in this pixel, then I plus 1 would move in this way. Then j, if this is I and if this is j, when I say j plus 1, I plus 1 would move in this way, j plus 1 would move in uh, this direction, right? So it will go here basically. Let me do one thing. Let me quickly explain you guys this by going here. Okay, let me quickly apply this formula here. 1 second. I'll take that formula there and explain. Just give me a minute here. So I will explain here. G of I comma j is the output that you want. Okay, is equal to summation of u equal to minus k to k and into summation of v equal to minus k to k into h of u comma v and f of I plus u comma j plus v. What is this I plus u j plus v? This is for your correlation operation. So I'll explain correlation and you'll understand clearly. Okay. So here, when I applying this patch on this patch on this, what happens? A into 0 plus b into 0 plus c into 0, so on and so forth. This 1 gets multiplied by I, so you get an I here. The central pixel will be I. But that's incorrect. I want A basically to be here. Okay. So what's happening? Let's understand. If I take u equal to minus 1 and v equal to minus 1 initially, so this ranges from say u equal to minus 1 to plus 1 and v equal to minus 1 to plus 1 into h of u comma v and f of I plus u comma j plus v. H of minus 1 comma minus 1, let's see. If I take u as minus 1 and v as minus 1, what would happen? It will become h of minus 1 comma minus 1. Okay. And into f of I, u is minus 1, so I minus 1 comma j minus 1. Huh. Now what is going to happen here is, here I need to first write down properly minus 1 what that means. Okay, so minus 1 0 1 minus 1 0 1. If it's like this, h of minus 1 would be minus 1 is g here into f of I minus 1 j minus 1. If this is I and if this is j, then it will become, this is, if this is ij, the central pixel, then I minus 1 would be going 1 pixel behind and j will be going 1 pixel behind. So it should ideally come here. Okay, 0 into that, 0 into that. Now, ideally, okay, so here, let me, I think I'm slightly getting confused here, but nevertheless, let me give a try. Here, if I take this 1, okay, with what is it getting multiplied? Let's see. Minus 1 to plus 1, minus 1 to plus 1, HUV, f of I plus u, j plus v, or do we have time? Let me quickly, yeah, we have time. So let me do this. This part, why am I getting confused? Let me go to AI Spry. I think last time also I got confused on this, but nevertheless, I will nail this right away. I have Yep. Um, just give me a minute. These are all my videos only. Okay. Not even fifth, if I'm not mistaken. Will not be here also. Okay. So it should be in this, if I'm not mistaken. Let me show you guys. Mm, sorry, friends, but you'll have to bear with me because that question our friend has asked yesterday also. I want to quickly clarify that. Convolution, convolution. Hmm. I think here also. Ah, okay. Same confusion there also. This number notation -1 plus -1 0 0 1 1. I should have taken it correctly, right? Anyways, I'll answer it now. So okay, let me answer it. The small mistake, I should remember this basically. So -1 0 1, -1 0 1. That's why I was wondering what is happening. Okay, anyways, let me see. So if I were to solve this for you, if I take u equal to -1 to +1 and k equal to -1 to +1, h of u comma v, f of I plus u comma j plus v. Okay, here when you take I equal to u equal to 1 and v equal to 1, h of 1 comma 1, right? That's what will become. And if you say u equal to 1 and v equal to 1, then what happens is this becomes f of I plus 1 comma j plus 1, right? H of 1 comma 1 is I 1 comma 1 is referring to I into f of, if you apply on this patch, this is your I comma j central pixel. This is what you are interested in. But then here, because of the virtue of the formula, what happens is it becomes I plus 1 j plus 1, meaning you are moving I along this direction, j along this direction actually. So you get here. So you multiply it with 1 and then you get I. That is the I which will go here. Okay. So what people thought is, hence your filter is getting flipped. Here you'll get H, here you'll get G, etc. Now, instead of -1, a very small change, if I make it, instead of +1, if I make it -1, then what happens? Okay. Then what will happen is you're getting I, if you take I -1 -1, I of -1 -1 is what? I, sorry, if you take u as -1 and j as -1, -1 and -1 is a. So h of -1 comma -1 and f of 1, it is -1 now, not +1. So here it is -1. So I minus u is -1, comma j minus v is -1. So it becomes I plus 1, j plus 1. And h of -1 is a. So a into what is f of I plus 1, j plus 1? F of I plus 1, this is f of ij. If you move I and j 1 pixel each, you get to 0. So it'll be a into 1. So you ultimately get this central pixel, which will be a. Okay, so you get the same values again. So that's a good thing. When you use cross correlation with a plus sign here, the filter was getting flipped on both sides. But when you look at your convolution, that issue is fixed. You're getting back your filter itself. It's not getting flipped on both sides. And from there on, people started using convolution, and hence the name of our neural network is called as convolutional neural network. Okay, we completed 30 epochs also, but then let me ask this to our friend because he was keen on this. Let me first ask him. Uh, where are you, my dear friend? Yeah, Yadagiri Rao, is it clear? Because I think yesterday also you were asking about this. CNN is used to handle images, RNN is used to handle textual data. Uh, Narendra, then can you share resources to learn complete deep? Kranti, again, as I've told you, see, one thing is I'm not a textbook guy. I don't know about textbooks, frankly speaking. So I cannot route you to any textbooks. But then I'm not a textbook guy, seriously. I'm practical guy, basically, right? So I cannot route you to any of the textbooks, but on YouTube channel, there are a lot of videos in our own channel. You can watch those or enroll for our main program. If you are very keen in learning in a structured manner. When I open few CSV files, it never opens in my system. What could be the problem? Can you take a screenshot, Archana, and share it with us? Okay, we'll look into that. Could be problem with your computer only. That's what I see. Yadgiri Rao has asked that question 3 times. Hope that answered your question. And Shubharani, it would be difficult. It's there on internet speech related data. Yeah, we also have AI training alone. We have AI training alone. So you can go to AI and deep learning. Here we have the AI training alone. The next question. Uh, do you have resource to learn completely? Yeah, I answered that, Kranti. Can we use textual? 1D convolution neural network can be used, Juice Mary. 1D ConvNet can be used for textual data. It is much faster. Thank you, Kiran. Thank you. It's 40,000 for AI training alone. Yeah, yeah. Whatever code I've used will be available. Yeah, Jyotsna, today we will be completing it. Yeah, because you'll have to give us some time. Everyone is occupied in the work. We will give you. We'll certainly share it with you. If uncountable images, if unlimited images are there, then neural network itself should not be applied, Usman Azim. Okay, because there has to be some count. Unlimited, infinite, you cannot run. Should not run. There is no objective of doing that, right? We will put that. We will put that, Tulsiram. If the images are not given, we will mention that. We'll put that. For 300 hours program, the course fee is 69,000. Vankudotu. Thank you so much, Venkateshwara. Sure, Tulsiram, we will do the needful. Same concept, Kranti Kumar. It's the same thing. Whatever we have done for MLP or ANN, right? In the same way, it will move forward, calculate the categorical cross entropy or binary cross entropy, and it will come back and update the weights. Same thing. Same, Kranti Kumar. It's the same thing which happens. Thank you so much, Amita. Thank you, Manjula. Thank you, Raghu. Thank you, Nagaraju. Thank you, Sheikh. Thank you. Thank you. Yeah, you'll receive it, Jyotsna. We will send it to you. Not a problem at all. Yeah, it's the same thing, Kranti Kumar. Python, Keras, and one more term is there. TensorFlow. These are all libraries, Saida. These are all libraries. Libraries are collection of code. Yeah, it's 40,000 and it's there. Uh, on the website itself, you can just go here to AI and deep learning and click on this, and the entire duration, you know, how many hours assignments, how many hours live projects is there. If you're planning to go with professional course, then entire all the details are there. What is the duration, assignments, how many live projects in that way. Anaconda is a distribution, Python is a programming language, Jupyter is an IDE, integrated development environment. Okay, then I am not really sure, Sadi Kumar. I think we'll have to look at what happens. Yeah, yeah. Supporting, if students have any doubts, they can join our YouTube live and then ask their questions, Tulsiram. We'll be more than happy to answer. You name it, Saida. Building robots, building chatbots, dealing with textual data, everything. Everything can be done using AI basically. No, you do not have any exam, Asha Jyoti, as such. All right, yep. Please do subscribe to our YouTube channel. That's the least help that I expect from you. And please provide feedback. Yeah, we also provide training on big data. Yes, absolutely, Adgiri. No, we don't give live projects to students actually, Kranti. They have to join our training, and only if they join our training, we give live project access. But for faculty members, for you all, we can onboard. But then we will have to check to what extent we can support you from that perspective. Is AI used in embedded systems? What kind of devices it can be used in? Yes. We do have IoT experts, industrial IoT experts, Dr. Saida, and I can put you forward to those guys, and they will be in a better position to answer. But we have built a lot of edge computing devices as well, and we have embedded deep learning algorithms into that. Sadi Kumar, we will put the data sets. Already data sets are there, Sadi Kumar. Only thing is for CNN, the cats and dogs thing that I've shown, except for that, all the data sets will be there on your learning management system. I just opened, it's there. So Pradeep, what you need to do is you need to go to our 360 Digit MG. Here you have the YouTube channel link at the bottom. This is the link, basically. Um, where I'll post that. Can you apply? No, you cannot apply the same code on MATLAB. MATLAB is completely different, Padma. But don't go with MATLAB because Python and R both have overtaken MATLAB long back. Long back they have overtaken. So you don't please take that route, because MATLAB is not going to help in a big way. The latest of the algorithms are not there in MATLAB, unfortunately. Yeah. So that's the YouTube link. Please click on that, subscribe. That's the least that I expect from you all. And we do, Vasudha, we do. For our professional training, we give you job placement as well, but with certain conditions. Yeah. Attendance link, Kavita, is there here on the sticky note. You can click on that. All right, friends, then. Thank you so much. Please give your feedback. It's very helpful. Python and R are the best tools for ML. To get access to your learning management system, all you need to do is drop an email to uh, smita at the rate 360digitmg.com. Yeah. Thank you all so much once again. No, we are not planning any in the near future, Vanilla, but we will keep you posted. No, there are certain things, Shobharani, which we look into, and then we provide them guidance. Certificate, we will record a video and post it on the YouTube, Raghuvir, and explain you on how to download the certificate. Yeah. Thank you all so much. And then Harita, you'll have to. Okay, I think. Harita, you'll have to drop an email to smita at 360digitmg to get access to LMS AI Sprite. Yeah. You can expect it in the next 1 week, Jaya. It will take 1 week at least for us to give you certificates. Yeah. Thank you all once again and have a good day. Thank you so much for joining in. Thank you all. No, no, R is statistical program. It's very good when it comes to statistical concepts, Ramchandra. Yeah. All right. Thank you all. Bye.